All right, boys and girls, welcome back to the drive-through, sponsored as always by the deli. Hungry? Stop by the deli. Get yourself a Answer chocolate on chocolate donut. Okay, this is a proof, number 9 from 7-4. We are given that AB is congruent to AD. And we are given that FC is perpendicular to BD. Okay, so we know that this side is congruent to this side. Not the best of pictures. And all right, so what I'm going to say right away, I'm just going to use my givens and take them a step further. So I'm going to say that angle FCB and angle FCD are right angles. Whoops. And that is the definition of perpendicular. And then I'm going to be able to say that angle B is congruent to angle D by if sides, then angles. So let me mark this thing up. I've gotten this, and this, and this, and that. Okay. So, I know from that picture, wow, I think I got it. I know from the third angle theorem that this angle here must be the same as that angle there. Can you see that? So I'll say that first. So angle CED is congruent to angle CED. BAD and what that does is that it shows that my picture is not very good. Okay, or the picture the book gave you wasn't very good. One of the two, or maybe both of them are true. But that's got to be true, right? This angle has a right angle and a single mark. This angle has a right angle. Oh, hold on. No. It's the wrong one. It's the wrong one. It's the wrong one. Do you guys see what I did there? It should be this one up there. That looks a lot better, too. Does everybody understand that? That's my third angle theorem. So, luckily for me, I've got a nice eraser. Let's see. Angle CED is equal to angle AFE is what I should have written. And that's called the no-choice theorem. Okay? Or you could write if two angles from one triangle are congruent to two angles from another triangle, then the third angles must also be congruent. That was from 7-1, I believe, maybe 7-2. Okay? Well, I think we're 2 steps away from having this done. We also know this, right? Vertical angles. Excellent. So we can say that angle CED is also congruent to angle FEA by vertical angles. So now we know that those two things are congruent to each other. Angle AFE is congruent to angle FEA by transitive. And now I know that I I may be going a step too far here, but I just don't like to call a triangle isosceles due to angles, even though I think the book may say you can do that. AF is congruent to AE by if angles in a triangle, then sides, and then finally I know that triangle AFE is isosceles by definition of isosceles. Boom!